In the last video, we discussed what a data type is, where data is stored in programming, and when to use which data type. If you haven't watched the video on data types, I recommend watching it first to clear your basic concepts. In this video, we will delve deeper into data types. To explain in simple terms, we will be understanding typecasting and data types. Typecasting is essentially the process of converting one data type into another. In C#, however, only compatible data types can be converted. Just like in real life, we can convert kilometers into meters, but we can't convert kilometers into rupees because only compatible values can be converted. Typecasting is heavily used in game development. For example, when a score is calculated, it is stored as a number, but when we need to display it, it is converted into text. This conversion from a number to text is what we call typecasting. In C#, typecasting can be done in two ways: implicit typecasting and explicit typecasting. First, let's understand implicit typecasting. Implicit typecasting is possible when a smaller data type is converted into a larger data type. Since this conversion does not result in data loss, it happens automatically. To explain with a real-life example, imagine you have a bucket filled with water and you pour it into a larger tank. Since the tank has a bigger capacity, it will store the entire water without any loss. Similarly, in programming, converting a smaller data type to a larger data type does not cause data loss. You might be wondering how implicit type conversion is done. The good thing is you don't need to write any special syntax for it. You simply assign the smaller data type value to the larger data type, and the compiler will automatically understand and perform the conversion. But how do you know which data type is smaller and which is larger? For this, there are several methods and properties in C# that help determine a data type size and range. For example, you can use the getType method to find out the type of a variable, the size of operator to get its size, and the min value and max value properties to determine its range. These can be checked in the Unity console as well. Let's look at an example of implicit typecasting in code. Suppose we have two variables, one of type int and another of type double. Since double is larger than int, we can assign the integer value to the double variable directly. When printed, the integer value is now stored in the double variable, demonstrating how implicit type conversion works. Next, let's understand explicit type conversion. If we reverse the earlier example and try to store a double value in an int variable, an error will occur. This happens because the compiler cannot automatically convert a larger data type into a smaller one. For this, we need to use a cast operator. The cast operator is written by placing the target data type in parentheses before the variable. For example, int variable in bracket, then variable name. This explicitly tells the compiler to convert the value. However, explicit conversion can result in data loss. For instance, if a double value like 1.3 is converted into an int, only one will be stored because integers do not store decimal values. This kind of data loss can also happen when trying to store a value of a larger range into a data type with a smaller range. For example, imagine pouring the entire water from a large tank into a small bucket. The excess water will spill out. Similarly, in programming, data loss occurs when we try to store a larger data type's value into a smaller data type. That's why explicit typecasting should be used carefully. So far, we've discussed converting number-based data types into other number-based types. But what if we want to convert a numeric value into a string or vice versa? For example, in game development, numeric values such as level numbers and high scores are often displayed as text. To convert a number into a string, we can use the convert class, Parse, TryParse, and ToString methods. By simply applying this method to a numeric variable, its value is stored as a string. Conversely, if we need to convert a string containing a numeric value back into a number, we cannot do so directly because a string is stored as text. In C#, we have multiple methods for explicit type conversion in such cases. One method is the convert class, which has several methods like convert.toInt32, which can be used to convert a string into an integer. For example, if a string contains 123, we can convert it into an integer using convert.toInt32 in bracket string variable. Similarly, the convert class provides methods to convert values into different data types such as bool, char, and byte. Another method is the parse method, which works similarly to the convert class but with a slightly different syntax. Instead of using convert.toInt32, we use int parse in bracket string variable. However, if the string contains non-numeric values, example hello, an error will occur because int can only store numeric values. To avoid such errors, we use the TryParse method, which first checks whether the conversion is possible before performing. TryParse method requires two parameters. the string to be converted, and a variable to store the converted value. If the conversion is successful, it returns true, and the converted value is stored in the variable. Otherwise, it returns false, preventing errors in the program. By now, you should understand how to use the convert, parse, and TryParse for string-to-number conversion. Similarly, if we want to convert a numeric value into a string, we simply use .ToString Method. This is useful in game development when displaying scores, levels, or other numeric data in a text format. I hope this explanation has helped you understand typecasting and type conversion in C#. Let me know if you have any questions.